sorry to get you going there. All right. So let's talk about the rate of change. When I say the rate of change in calculus, you think of slope and derivative, okay? Probably more slope, but calculus class, I want you to really think of derivative, okay? So if I say that the rate of change of a quantity is directly proportional to the quantity itself, okay? That means direct proportional, if y is directly proportional to x, y equals kx. That's something that you did way back in algebra, okay? Y is directly proportional to x. It's like a line, right, with slope, okay? Where k is the constant of proportionality. So if the rate of change of the quantity, dy, in this case dt, because we're going to talk about time, so instead of x, we're going to use t. So the rate of change of a quantity, the derivative, is directly proportional to the quantity itself. dy dt equals ky. All right? You are going to see that sentence a lot. The rate of change of blah, blah, blah is directly proportional to blah, blah, blah. Okay? When we see that, we know that we can write dy dt equals ky. Now, let's go ahead and use our skills here. Oh, no. To actually solve that differential equation. Okay? Whatever. Okay. All right, so if I'm going to solve this, what do we do? Divide by y. So we have 1 over y dy equals k dt. Okay? Looks familiar. Antiderivative of 1 over y is the natural log of the absolute value of y. Antiderivative of k dt, dt plus c. Okay. So now to solve for y, those are going to cancel. And since we're taking e to a power, we know y is always going to be positive. No need for the absolute value anymore. Y equals e to the kt times e to the c. All right, we can break it up like that. And we know e to the c is still a constant, so y equals what does it remind you of? Exactly. It is PERT. Okay. I think I have a group of students who call it KET. Not as cool as PERT, but it's exponential growth and decay. Okay. We're not using PERT because we're not talking about money. Okay, and that's technically what PERT is for, but it's the same concept. Okay. C is still your initial amount because if t is 0, y equals c. All right, and k is going to be your rate of increase or decrease. Okay. Now, what we can do with this, if you see the words, the rate of change of the quantity is directly proportional to the quantity itself. Instead of writing dy dt equals ky and solving it out, just remember that the solution to dy dt equals ky is this. Okay? We did the differential equation once. Don't have to do it again. Sound good? Okay. where my scroll bar is. So example 1, the rate of changes of y is directly proportional to y. Boom, what does that mean?
Y equals C E K T.
Perfect. When t equals 0, y is 2. When t equals 2, y is 4. What is the value of t equals 3? All right. Now it becomes an algebra problem. An algebra problem that you've probably done before. Okay? So we need to determine what c and k are, because y and t are variables like x and y, right? All right. So when t is 0, y is 2. What does that tell us? That c is 2. Okay? You wouldn't even need to plug anything in. When t is 0, e to the 0 goes away and you're left with c. All right, so c is 2. Now, when t is 2, y is 4. So y is 4 when t is 2. All right, here comes the fun. What? Okay. 2 equals e to the 2k. How do you solve for that? Okay. The natural log of 2 equals e to the 2k. So k is the natural log of 2 over 2. Yeah, which is what I was writing in my mind. Thank you, Joe. All right, so what is the natural log of 2 divided by 2? Point 3, 4, 6. Give me 3 more. Okay, if we're in around to 3 decimal places later, you probably want to round to twice as many within your problem for that k value. Okay. So now what we need to do is we need to figure out what is the value when t equals 3. So we get to plug in 3. Y equals 2 e to the 0.34657 times 3. Thank you. Trevor?
You actually actually solve for t equals 3. Do you actually want to use actual 1 and 2 or 2? So it's like more.
Probably what I would do is I would put like second answer in for that instead of typing it out. It's easier, right? If you really want to sit there and say 0.343, right? Just recall that answer, and I think that would be a better way to do it. Thank you for bringing that up. I didn't mean to say that. Yeah. I would not waste your time typing in a bunch of numbers. Just recall that answer. So when you do that, what do you get? That? Yes. Did anybody use the rounded k and still get the same thing? All right. Class? Very straightforward. Let's look at 2 more examples. Turn to the back and read through example 2.
Not the
Yeah. Okay, so some of you are having flashbacks. Flashbacks to chemistry? Chemistry. Okay. So 10 grams of whatever was released. What is this?
Plutonium-239.
Do you know what that is?
It's the mass, right? It smells really good.
Smells bad?
Yeah.
Okay.
Well, the radiation's for you.
I will always remember that.
Fingers crossed your mind.
That is a great way to remember those things. Okay, now I gotta get back on track. Okay. So it's basically telling you that it's exponential decay because we're talking about half-life, right? And those of you who have had chemistry, you know that, right? And I think you even maybe talked about half-life stuff in algebra too. Maybe? Yeah, slightly. Okay. So really, this has nothing to do with calculus at this point because it says nothing about the rate of change being proportional to blah, 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 blah. Okay? So really, you're not doing calculus.
Well.
Okay? Now, 10 grams was released. What does that mean? That's our initial value. C is 10. We need to determine what K is so we can figure out how long it will take to decay to 1 gram. It gives us the half-life. Okay? What's half of 10? 5. So we start with 10 grams. It decays to 5. Okay? And it takes 24,360 years? Years. Okay? Watch what happens when we take y divided by c. What do we get? Do you think that is a coincidence? No. We don't even have to know the initial amount to know that y divided by c for half-life will be 1/2. You see what I mean? Okay? We did not need to know that c was 10 in order to know that that's going to be 1/2 equals e to the kt. All right? You're going to find problems like that. I want you to be aware. All right, so now we know that we have the natural log of 1/2 equals 24,360 K. What is K?
Well, it was a question.
Yeah, question. Questions are great.
So wouldn't it always be like natural log of 1/2 equals whatever amount of
Yeah.
use?
Okay, so you get like negative 2.845 times 10 to the negative 5th, right? You know what I would do? I would store that in your calculator, which is very easy for you to do. Okay? I'm going to write it down, but you know what I'm going to do? This is what I'm going to do. We want to know when it decays to 1 gram. So we know that we want our final amount to be 1. So we want 1 equals 10 e to the kt. And I know what k is, but I'm sorry, I don't want to write it right now. Is that okay? What? Okay. So if we're going to solve for t, I have 1/10 equals e to the kt. The natural log of 1/10 is going to equal kt. So our time is the natural log of 1/10 divided by k, which I have stored in my calculator, and I can just recall it from there, right? You can say second answer, or some of you have the 84s where you can just arrow up and hit it, whatever you need to do. Okay, do you have time? Oh, well, all you need to do, let me get my calculator out. Let me just get it out. And you don't actually need to do the store. I'm sorry to mislead you. If I have the natural log of 1/2 and I divide it by 24,360, right? That's my k value. So when I'm right here, I'm doing the natural log of 1/10, and I need to divide by k. Well, k is what I just put in my calculator. I can press second answer, and it recalls that number. Oh my. So not in this lifetime. Okay, so really no calculus involved in that problem, right?
Algebra.
It's a lot of algebra, all right? Which is kind of a nice break if you want to know my opinion. Okay, third example. And then what's going to happen is I'm going to give you some time to begin your assignment before we transition to taking notes on slope fields. I got to remind myself, we are in here 9:45. Okay. Okay, read through example 3, please. Okay, the rate at which the acreage is being consumed is proportional to the number of acres already consumed. What does that mean? It means test. Yes. Okay. Where Y stands for number of acres consumed. Yeah? Okay. So we know dy dt equals ky, which means that. All right. Perfect. What do we know? We know that there are 2 acres consumed when t equals 1. So y equals 2 when time is 1. Okay? And we know that 3 acres are consumed when t equals 5. Now I need to solve for k and c. We have 2 equations with 2 unknowns.
separation of variables.
Well, you're thinking in very calculus terms right now. System of equations, which I think is what you were going for, Trevor. The system of equations. Okay? So we have two very predominant ways of solving systems of equations. We have substitution and we have elimination. Elimination is probably not going to be the ticket because we don't have lines. Okay. So let's try some substitution. So what I'm going to do, I'm going to go to this one. It has the smaller exponent. And you'll see why I do this here in a moment. So C equals 2 over e to the k. Do you agree? Okay. So then I can come over here and I can write, well, instead of C, I can write 2 over e to the k. Okay. 2 over e to the k times 5, times e to the 5k. Similar basis? Yeah, so when we squish them together, we get e to the 4k because we are subtracting. We're dividing by e to the k. So this becomes e to the 4k. So we have 3/2 equals e to the 4k. We know we need to solve for k, so we're going to take the natural log. So we have natural log of 3/2 equals 4k. So we have the natural log of 3/2 over 4, which is 366. Okay, beautiful. Now what we can do is we can come over here and we can plug it in to find our C value. Okay, my suggestion, we know that C is 2 over e to the k. So my suggestion to you, because in your calculator you already have the natural log of 3/2 divided by 4. Okay. So for C is 2 divided by e to the k. I would just call up that answer. All right, so you don't have to type it in. And our C value is 1.8072404. Okay. Okay. So how many acres will be consumed when T equals 8? Well, we just need to follow our model. Y equals C e to the kt. I'm asking for when T equals 8. So essentially, you need to plug in 8 for T. And you already have C and K in your calculators, or type them in because we rounded. And hopefully you see your answer in one of those 5 choices. A, B, C, or D? Or E?
C.
Beautiful. Beautiful, beautiful. All right. What I'm going to ask you to do, you are not probably going to finish it, but I'd like you to begin working on your book assignment. So reference your gold sheet. I'm going to give you 20 to 25 minutes. I haven't quite decided. 9:05 or 9:10, we'll get started on our second set of notes. Okay?